Can you hear me? Oh, yay. Are you going to stay muted the whole time? Is this I'm just going to talk and you're going to react, and that's going to be the show. We're in the presence today of, and for all future weeks of this podcast, of somebody very, very clever sat on the other end of this call by the name of Jesse Cross, and he has just a wealth of knowledge within him, specifically around physics, but also around other topics, which I can't even list a single one, but I'm sure you have other banks of knowledge, and so we're going to explore some of them. And then we can all become a little bit cleverer at the end. That's how I see this going. Is that how you see it going?
Yeah, me too. Basically, we're gonna rob our own egos to
yeah.
And yeah, exactly. Basically,
so I'm going to tell you how clever you are, and you're going to tell me how clever I am, and then it seems more modest than you saying, actually I'm very clever. Here's what I'm going to teach
exactly.
you.
That's the way to do it. So I'm going to tell you you're very clever in a second. I actually wrote down a bit of information about you to tell everyone.
No, you didn't.
So you can imagine it like at the beginning of a lecture when you have like a guest speaker and they're like, this professor has these awards and this and did this and this, and we're very lucky to have them, sort of thing. I've done that for you on a very basic level.
Sure. So I hope you included...
The main reason, sorry.
Yeah, no, carry on.
I was just going to say the main reason I had to write it down was because the degree name you have is infinitely long. So I had to write it down in order to get it right. It's not quite as simple as... So.
No, you're right. Okay.
And you're very clever in all of these disciplines within. It's quite funny that you say actually that I'm clever in many areas, right? Because Fiona said about doing the mastermind quiz recently. And think of a topic to do, and then we can all quiz each other on it. And my head instantly went to physics.
Yeah.
And then I was like, that's just so stereotypically me and boring. I can't do my degree. I need to think. I know loads of stuff. I'll think of another topic. And then I sat there and I spent a good section of the day thinking, I can't think of anything. And in the end, I went to Doctor Who because that's physics still, sort of. Oh God! And I mean, I have to do. I haven't watched Doctor Who for about 4 years, but maybe I still know a lot about it. I used to be an avid fan, but it's really upsetting that I couldn't think of another topic that I knew a lot about. And it made it even worse, when you came along and said some random, real niche play that I've never heard of. And I was like, of course,
You've never heard of it.
I've never heard of it. Darius heard of it.
The most upsetting thing you've said so far. It's Joseph and the Amazing Technicolor Dreamcoat. You've never heard of it. I'm so upset.
I'm sorry. Darius heard of it, and she was surprised I hadn't heard of it.
Dara is learned, so that doesn't surprise me at all. Maybe I should give you less of a glowing introduction. Now that, can we redo that bit?
Right. Yeah. So I'll introduce you then. So I'm here with Mickey. I think the point in this is basically we just wanted an excuse to dive into each other's minds, right? And we both find each other quite interesting, and we thought the format of a podcast might be quite a good way to catalyze fun discussion. And then we'll put it online, and if we get a few viewers, why not? But that's great. But...
And if we don't, then will we be sad?
Well, nah, we'll be all right. We'll be able to look back on this and have a laugh maybe in a few years' time. Something that we've done during lockdown, during the coronavirus pandemic.
That's true.
Which one is it? Pandemic or epidemic?
It's a pandemic. A pandemic has gone across multiple countries. Pan meaning every.
Of course.
Theon, for example.
Of course. Viewers. We learn it all the time.
Indeed.
Yeah. So Mickey is a very clever boy. He did a degree in 4 different things and more. And
That's just such a lie.
Ricky has a degree from University College London in neuroscience and psychology and mathematics and statistics. And I don't say the "and" to exaggerate each topic. That is the name of the degree. UCL don't know the existence of content, apparently.
No, that's true. Yeah, so the reason there's lots of "ands" is because it's natural sciences is the overall degree, but you choose work streams is what I'm going for. So, for example, I could have been physics and organic chemistry, right? That could have been my thing, but I just happened to choose the 2 topics that have the word "and" in them. So neuroscience and psychology is one stream, mathematics and statistics is another stream. So it could have just been physics and chemistry, but it mine happens to be 4, which just makes me sound like I've done 4 years at uni, like 12 years at uni to get 4 degrees. That's not what's happened.
It makes it sound like you have 4 degrees. I love it. It's brilliant. That makes more sense. Yeah, that makes a lot more sense.
But yes, I'm glad.
But the thing is, it's very cool because your degree has made you sort of, I suppose, I don't want to inflate your ego too much, a bit of a polymath, I suppose, right? You've dabbled in a lot of different areas, so I feel like you're someone who always has something interesting to say, or at least engage with an interesting discussion on something you don't know a lot about, just because you've sort of maybe dabbled in it yourself at one point, you know?
No, I'm glad you think that. I sometimes think I've gone through a whole day just talking out my ass and somehow managed to survive and people not realize that I don't know what I'm talking about. So I guess there's 2 sides to that coin. But yeah, no, I'm glad you think so.
I think that's how you get anywhere in life, isn't it? You just pretend you know what you're talking about until you get there, and then you learn once you're there.
This is true. Very true.
Yeah. Like we give life tips on this podcast too, by the way.
All right, let's do it. I'm ready. Which one of my 4 degrees do you want to quiz me on?
Well, I suppose the first 2 would be quite interesting to dive into first. So you spent the first summer between first and second year of your uni doing some research with the KARE project, right? Which is ketamine for reduction in alcohol relapse. I'm trying to remember it. So it's to do with using alcohol to help people who are addicted. Using ketamine to help people. Oh no! We made it. We had a good start.
I'm gonna get sued by my former employers. We just give alcoholics alcohol, and that's all we do. If there's ketamine involved somewhere, no one remembers.
Right. I'm gonna introduce it properly. So you were researching, doing trials to investigate how ketamine could be used to help people not relapse when they were coming off their alcohol addiction, right?
Absolutely.
You were involved with that research, and you did that during your sort of first to second year summer as part of your project. It was with I think I was looking into it, did a bit of research. You were doing it's with UCL, but the project is initially with Exeter.
That's right. Yeah.
Okay. Cool. So, I suppose it'd be interesting. Could you just sort of start what was it about?
No, absolutely.
Tell us a bit about it.
Yeah. So, people who have an alcohol addiction often struggle to come off it. Right? It's known for being quite a nasty addiction, and there has been evidence in the past of psychedelic drugs being used to change some sort of neuronal structure in the prefrontal cortex, which is this part of the brain here, which is involved in this sort of thing. So it's been shown to work with things like depression. Now, depression obviously isn't an addiction, And like, I want to say very loosely, like it affects the brain in a similar way, although anyone who's studied neuroscience is going to immediately pounce on that. But it does, there are some similarities between the two. And so there was grounds to believe that it may work for alcohol addiction as well. Now there's a professor called Professor David Nutt who's written lots of books about this sort of thing, and he is adamant that LSD is the absolute best drug for this, because I guess it's one of the more psychoactive drugs out there. However, LSD was completely banned in the 80s when people started taking it recreationally. The governments, I say quite a few, got very scared of it, and so just banned it completely, including for any medical research, and that has not been lifted. And I don't know enough about it to say whether or not it should be, but Professor David Nutt is adamant that it should absolutely be lifted and it could cure a lot of things. But ketamine is normally used as an anesthetic, and so is medically available, but it is also very slightly psychoactive, so it can have similar effects. So that's why we wanted to treat the alcohol addiction in this way, and it's why we use ketamine to do it. Yeah, so that's sort of the background. Yes.
So I suppose psychologically, what is the point that it's trying to make the person more impressionable so that then you can treat them for their issues with alcohol better?
Yeah, actually, that's a really nice way to put it. Making them more impressionable. So you're like, if you imagine an addiction is like your neurons are configured in a certain way, right? That's what determines how you think, what your behaviors are, the movements you make is all to do with your neuronal structure in your brain. And when you're in an addiction, your neurons are configured in a certain way that's unhealthy, and they can't stop, right? They don't break from that formation. And that's what leads to this addiction and the feeling of being stuck in a rut, right? And what ketamine does and other psychoactive drugs, they sort of loosen it. Your brain is very plastic. In fact, it's called neuroplasticity, right? Your neurons can be molded in a way, and the psychoactive drug makes it easier to mold them. So the way the trial worked is that the participants, it's a clinical trial, so there was obviously a group of people who were not given any of this because there had to be a placebo group, but those who were on the actual on the medication were given really intense like psychotherapy, which you could be given normally for alcohol addiction, right? Just really, really intense therapy to try and get you out of that mindset. And then they were given the ketamine, which was sort of low dose infused over 40 minutes rather than taking it as a hit like you might do recreationally.
How do you take it? Sorry, like, is it because recreationally it's often like it's snorted like a bump or something. How do you inject? Do you inject it or ingest it?
I've never heard. So you call it a bump. Very good.
I think
we weren't bumping our patients. We were no, it was intravenously. So just sort of in a bit of saline solution. So
okay.
So just flushed around their body for 40 minutes or so. And the participant they were sort of asked to really focus on the therapy they'd just been given, so that while their brain was a bit plastic, they're really focusing on trying to fix that addiction, right? Some techniques that were given by the doctor. And the hopeful outcome is that the combination of the two makes the therapy much more powerful and the results much longer lasting. Yeah, so that's the plan. And like, so the trial was double blind in the sense that neither the patient nor the doctor knew who was getting placebo and who was getting actual ketamine. But for safety reasons, of course, you have to monitor a patient's heart rate and blood oxygen level just to make sure they're okay during the transfusion. It's not a transfusion. It's whatever, when they're getting the treatment. And when you're on ketamine, your heart rate like shoots through the roof. So it was quite obvious when people were on ketamine. And then obviously, like, you know, some people started hallucinating and started talking to me about elephants and giraffes. And I was like, we're in a hospital. There's none of that in here. So yeah, while it was officially double blind, it is like it was quite obvious to all involved.
What's that like? What is that like in terms? I've never. That must be so interesting. So the hallucinations, is it to the extent where they believe what they're seeing, or do they know that what they're describing, like the elephants or whatever, isn't real, but they're just seeing it. Like, to what extent is the hallucination impacting them?
No, it was, unfortunately, it was mild.
Okay.
It was just in the sense that, like they were told to, they didn't have to close their eyes. I don't think they could keep their eyes open. They had sort of relaxing music playing, and then they were just told to think about whatever. And then halfway through, I had to sort of wake them from that state, just to ask them a few questions about how they were feeling, to make sure, that they weren't going completely mad. And it was during those sort of midway chats we'd have where people would be like, "Oh my God, a minute ago you were an elephant." It's only when you started talking I realized you were human. So yeah, there were lots of that sort of thing. There was no one who sort of pictured anything wild happening and got scared or anything like that. It's quite a low dose, and I don't think ketamine's that psychoactive. So so yeah, it was funny though. It's funny seeing people wake up and yeah.
Well, what got you interested in that kind of thing? Did you just sort of stumble across that, or because your bachelor's project was related, right? Or it was related to alcohol addiction as well, right?
Yeah,
So
yeah,
have you always been interested in that sort of area, or did you stumble across it and then just go with it?
Yeah, I think more the second of those two options. It was like an opportunity that was presented to all of my cohort, and I wanted to, like, it seemed like a good opportunity to help people and to keep busy during summer, and also, like a really keen first year science student at university. I was like, oh, this is exposure to a lab and to a clinical trial, and I could get a job in doing this one day. Little did I know. But yeah, so it was just sort of, I was very keen. When I was younger, and then once I'd done that, I thought it'd be quite nice to keep in touch with the folks. Like, it's a really important trial, I think, that they're doing, and the results are exciting, and I was keen to stay involved. So I did sort of a mini project on it in second year, and I did my dissertation in that general area in third year. We kept it going, and then haven't touched it since.
No, so you really did sort of follow it through for the whole degree. You sort of had a bit of a vision for it, I suppose, and built on it.
Yeah,
that's really nice. It's strange, isn't it? Like, I think that's really common at uni, to sort of stumble into what you end up focusing in on and researching. That's what happened to me. Like, I never thought that I would end up in fourth year doing my project in statistical analysis, in like astrostatistics. Like, it's statistics and coding. Like, I couldn't code 3 years ago, and statistics was my least favorite area of maths back at school, and I don't know how I've ended up here, but it just seems to be the way of uni, right? That you just stumble into something and then suddenly it's really interesting, just because you focused in so much that it's exciting.
Yeah, no, definitely. And I think it's nice in what you're describing as well, because you have all of your other areas of interest, like other areas of maths and other areas of physics, and then you do a project in two areas that you perhaps wouldn't be otherwise interested in, right? Coding and stats and maybe astro as well. So you have all the grounding of what you're really interested in, and then you also have this massive project you've done in something else, and your portfolio and your knowledge just increases massively as a result, right? If you've just done your project in something you're really comfortable in and familiar with, you would have lost all of that statistics and coding side of things that you now have. Another tool to your belt.
Has it sort of changed your perspective on drugs, doing your research into it? Has it? And what is your perspective? Because last time we talked about this a while ago, and I don't know, I'm interested to know if your perspective shifted since, or you're broadly speaking for the laws against drugs. Like, you think they should be illegal, right? Or would you or is your perspective a bit more nuanced than
that? Drugs are bad. Yeah, no, I don't know. I'm really torn, and probably I don't know enough about it to have a valid opinion. Yeah, I mean, I can see there being a world where they're all legal and they're regulated, and there's a lot less, a lot fewer deaths caused by it because they're higher quality. I can completely see that being the case. I think my perspective has definitely changed since we last spoke. But again, like, I can see a future where that is beneficial, but I can also see that going horribly wrong. And this, you know, I really don't know enough about it to decide if that works or not.
I think that's crazy, right? Though, because it's always the people. I really take the perspective that people who become more knowledgeable in an area become more humble in their opinion and claim to know less. There's some really interesting. I don't remember the. I think it was a philosopher that talked about it. There's this sort of chart that just sort of talks about how the more you know, at the beginning, when you know nothing, you feel very not confident in what you don't know. And then very quickly, if you know a tiny bit, you're insanely confident, shout about your opinion, blah, 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 whatever. Everyone has to hear about it because you know a tiny bit about it. And then suddenly, sort of, I suppose, as you get to uni level, you just drops off massively, and the more you learn, you just feel like you know absolutely nothing at all. I just feel like I spent my entire degree going, there's just too much in every direction. I have no idea. And then until probably like high level research do you start to feel very knowledgeable about one very specific area. And even those kind of people will be really humble, generally speaking, maybe not always, but about their opinion on it. They'll always question it. They won't say things with absolute certainty. And it's like it's the opposite of what we need in society, right? We need the people who know more about stuff to have a more confident voice on these things to counteract people that because we are all those people at the lower end on some topics, right? We all like to think we know a lot about something we know very little, and I've been victim to that many times. But it's just I just noticed you did it then. Like I feel like if of anyone I personally know in my circle, you would be someone who has an opinion I would respect more on that topic because you've worked in a research group with drugs. Like loads of people love to talk about drugs, right? Because it's just like one of those things humans are fascinated with. Not many people have worked with them in a scientific way and studied it, right? I just think the psychology around that is really interesting, how sort of we humans behave with regards to talking about different topics.
That's very true. That's very true. I don't know. I guess with this one, right? You're like, I know, I feel very strongly about perhaps once the results of this trial come out. Obviously, I can only see the preliminary ones / like what I saw with my own eyes, but it was very promising. The results were very promising. So I'd be very sort of forthcoming with my opinion that actually, if it works, then and the results are good, then we should be having this in the NHS and potentially destigmatizing the word ketamine and using what are now recreational drugs for medicinal use. But to extrapolate that view to just drugs in general, even to the point where if you said to me, I'm struggling with booze and I've managed to procure some ketamine, can we sit down and do the trial? Like I would feel very I would know. In fact, I would feel very uncomfortable, right, in that situation, because even though it's a very similar setup to what I know works, just extrapolating it to outside of a medicinal setting, outside of a hospital, maybe taking the drug in a different way, all of a sudden I'm like, well, I don't know if that works, right? Because I know how specific it needs to be to work. Whereas maybe if I told this story to someone haphazardly and then their friends came to them and said, I'm struggling with booze and I've got some ketamine, they'd be like, oh yeah, just snort the ket and let's have a chat.
But that's the thing with the science, right? You have to have these really well specified conditions under which you carry out these experiments, right? And with something like a drug, it's going to behave differently depending on the dosage. So I completely understand your viewpoint on that. It's like it's controlled. It's controlled when it's in a research environment. It's not in real life.
Yes. But it's a good point you make. The more you know, the more you don't know. And I guess once if you keep going along that curve that you described, there's always somebody, let's say with maths, for example, right? Like there's always somebody who knows more about maths than you do in a niche area. And then you learn more about that niche area, and there's someone who learns more about it. And you keep going and going and going. So you always feel like you're more ignorant because you know how much you know more what there is you don't know, the more you do know. And then I feel like when you get to the end of that, when let's say you are the most knowledgeable person in the world about a certain area of maths, then I think you're just staring into the void, right? Because then you know just how much there is you don't know, and you also know that no one else knows it, and you don't even have that to strive for. You know, you can't learn off anyone else, you can't use anyone else's work. You're staring into the darkness with absolutely nothing.
What an epic weight to hold that you've got to like. I'm the front line to this. I'm the one chipping away at all of that, and everyone else behind me is like following.
Yeah, I mean, it must be amazing, and that is something that I have never, obviously never experienced, and I can almost guarantee never will. But it does bring us nicely on to you. So, you, Jesse, you're a physics master's student at Imperial College London, integrated masters. Indeed.
Yeah, integrated masters.
But you're in your master's year, is that right?
Yeah, yes. That's right. I've started my research, so to speak.
Yeah, and you're studying physics, but more broadly, you're interested in theoretical physics. And as you mentioned earlier, you're doing some statisticky, astro-codey, those prefixes in some order.
Yeah, so like my degree's in theoretical, well, the title is physics with theoretical physics, which similarly to your degree, I don't understand why it's named like that. Why is it not just theoretical physics?
Right.
it is what it is. I'm doing theoretical physics, which all that means is basically I do less lab work, experiments, and more maths modules, basically. I sort of did that just because I really enjoy the maths, not because I dislike the experiment too much. But I've ended up doing my fourth year project. Broadly speaking, it's astrophysics. Yeah. It's the statistics of astrophysics, and it's my project is very specifically doing some computational stuff. I'm using Python, the coding language, to fit some models to some data, and that data is collected from light emitted from hydrogen throughout the first billion years of the universe.
I see.
and from that we can hopefully have a bit of an understanding of how the universe evolved in the first billion years. When did the stars form? When did black holes form? The first ones. Just the evolution of things, really. But that's the sort of big picture. What I'm doing is sitting at a computer trying to code a bit of statistics to fit a bit of data. It's which is really interesting in and of itself. But it's when it gets so niche and specific, it's so distant from the bigger picture.
Yeah, absolutely. And you spend a long time doing lots of work, and then it just sort of fits into a tiny little corner of this area of research. That's very true. Okay, I mean, I didn't plan to ask you about that, but now I'm really interested, so I now want to ask you about that instead. Is that okay?
Absolutely. Yeah, absolutely.
Okay, so how does studying the light emitted by hydrogen atoms in the first billion years of the universe tell us anything useful?
Interesting. So I think the reason we look at hydrogen, light emitted from hydrogen, is because hydrogen is the most abundant element in the universe. So it's the first element in the periodic table. You sort of learn that in school chemistry. It's the simplest element, and there's just so much of it. It's the first thing to have formed. Stars are made of it. The sun burns on hydrogen. So there is it's everywhere. There are hydrogen gas clouds that are light years across. Like, it takes years for light to travel these clouds of hydrogen gas, right? So there's just so much of it everywhere. And hydrogen's also, because it's the simplest atom, we understand it really well in terms of the physics of it compared to the more complex ones. So you get, when it emits light at a really specific frequency, it's actually a microwave frequency. It's 21 centimeters. That's the area of study. It's called 21 centimeter wavelength astronomy. For the not get too tell me if I'm getting too technical. But what's cool is that hydrogen always emits this light at this frequency, this wavelength. So we know that. Then, so wherever it is in the universe that it's being emitted from, it's reabsorbed. It's absorbed from somewhere and then it re-emits it. Wherever it's emitted from, it then travels, and it will travel through the universe until it reaches Earth, for example. That's where we're detecting it from. And as it's traveling through the universe, time passes, thousands, millions, billions of years. And as that's happening, the universe is expanding. We know that the universe is expanding from observational, empirical data. We know that. When the universe expands, and by that literally mean space is expanding, not just objects between each other moving apart. It's like the fabric of the universe is expanding. A bit like how when you blow up, if you consider a balloon, like the 2D surface of a balloon as like the 2D fabric of the universe, when you blow it up and it expands, it's like if you drew two dots on it and then blew it up, those dots would move apart. It's because the space, the surface of the balloon is expanding. And that's what the universe is doing, right? And when it does that, light also stretches. So what happens is you get wavelengths of light stretching out. So this light emitted from hydrogen stretches as it travels through the universe. So the frequency changes. It changes from microwave to radio wave. It becomes longer in wavelength over time. It heads in that direction along the spectrum.
Okay.
So depending on how long this light's been traveling through the universe, it's stretched by a different amount. So we got this huge telescope. It's which sort of looks out into the sky. It's called EDGES. It's in Australia, I think, and it's detecting these radio waves, and it's detecting between a range of frequencies. I think it's about 20 hertz to 100 hertz. So that's sort of the radio frequency, radio wave length. And the reason we're detecting a range, even though we're looking for the very specific wavelength of light emitted from hydrogen, is because we want to look at different light emitted at different times throughout the universe. And so each frequency that we detect represents that light emitted at a different part of the universe at a different time. So the frequency, the longer the frequency is, the shorter the frequency is, the longer the wavelength is. The older that light is. So the further back in time you're looking, you can look at different frequencies to look further back in time. And from that, then we can see what we can take pictures of what the universe was like at different times. And we're looking specifically at the first billion or so years, because that's when stars evolved and galaxies and black holes, all the first initial things. That's why we're looking at hydrogen, because it's just, there's so much there, and it's hopefully quite easy to detect. What we're trying to do is we're trying to see if we can detect it. Actually, right now we don't actually have evidence that we have detected it yet.
Okay. So how do you know all of that then? If you can't see it, how do you know it's happening?
So we know all of that because we know other areas of physics. We know atomic physics because we can study hydrogen here on Earth or in the sun and see how light's emitted. We know about cosmology, cosmological expansion, how the universe expands, because we've observed that through different methods. So what we're doing is we're combining other areas of physics to come up with this theory that, well, the light must have stretched, so we must be able to detect it in this region. The reason we haven't detected it yet is not because the signal is potentially really faint and we can't do it. It's the real reason we think is because there's too much noise, too much foreground or background noise. Because when we look up at the sky, the only thing, we're not only seeing this signal. There's so much stuff going on in the universe, and there's so much stuff going on in like our atmosphere and radio waves that we emit. We produce so much noise, like from our radios, TVs, satellites, things like that. But then there's all other things, like we have nearby galaxies, stars, interstellar objects that are producing this kind of light, but through different processes. But it just happens to be in the same frequency range. So it just produces so much noise that's in the way. And what I'm trying to do is, what I'm going to be trying to do, I'm still at the stages of learning about it, like, and just trying to understand the statistics of it. But I'm going to be a very, very small part of trying to separate the signal from the foreground. And we're doing that through sort of simulations and looking at some data that a group collected a few years ago, and they claim to have found the signal, but we're trying to work out whether or not they actually did or not. We're doing some peer review basically and trying to find out if it's the real signal or not, and we're not sure at the moment. And there's loads of different techniques for separating the signal, right? So it's that's what I'm looking at.
Yeah, so that was about to be my next question. So you get this signal, this eureka moment from a different group somewhere else on the planet, and they've shipped all their data to you, and you're sat there with the data in front of you. And do you want to decide whether or not they've just seen me listening to my transistor radio at home, or whether they've detected some hydrogen? What do you do? Let's see, can you explain that even without saying words that I immediately don't understand?
So you do something, you try and fit models to the data. And what I mean by that is you have a model for the foreground noise, for example. You try and work out what that foreground noise is. And when you know what that is, say, for example, there might be something to do with tracking over a certain area of the sky that has a signal from a very specific object in the sky, like a neutron star or a sun. I'm using those examples. I don't know if they emit specifically in that frequency, but an object like that. And then you go, how do you factor that into your model and then remove that from the data? Or for example, could there be noise in the instrumentation that you try and like maybe there's some kind of systematic thing where there's some kind of feedback in the radio telescope, and it sort of that's been going into the noise. So actually you're detecting the instrument itself. To try and remove that. We need to try and work out whether we can remove that and how you do it. And that's like subtracting away that factor into the noise. And then you also need to model the signal itself. So we have theories about how that signal will look. And you need to try and fit different versions of the models to it and see how well they fit. And you fit those models to it as best you can. And the one that has the least errors is the most likely, broadly speaking.
Yeah, oh, that's very interesting. So I was imagining that you'd do you'd model what you think the hydrogen's going to look like, and then you sort of see what matches it. But I like the idea that you can probably detect quite nicely what a foreground noise is going to look like, or you can probably model that more accurately than you can model this hydrogen. So you can then detract that model from the sample you've got and see if you're removing that noise, and eventually you'll be left with what you're looking for. That's really interesting. I like that. I wouldn't have imagined that approach, but it makes complete sense why you do it that way.
Yeah, I mean, the foregrounds are the thing that are in the area that we're looking at, the biggest focus point. There's a professor at, I think it's at Cambridge, Hills. He's looked a lot at the foregrounds and sort of and tried to model this data basically on trying to see if the foregrounds are the thing that we can remove largely. And we're looking at, well, that's where we're initially looking to investigate further. I don't know if that's exactly the route we'll go down, but that's where we're sort of starting our little research at.
Yeah, great. Okay, so let's say in a few months' time, or if you want, in 15 years' time, we've managed to get this group has actually found. You've decided that they've actually found this hydrogen, and it's a real sample, and it's not fake news. And you collect loads more of this data, and you build up what is quite a comprehensive map. And you can do all your modeling and your statisticaling, and you get somewhere quite exciting with it. What happens? Why is it important?
Okay, so well, hopefully we'll get better data from the telescopes. That means that we can fit the models that we're trying to design now to that data to detect it. And then once we've detected it, it gives us a better picture of the earliest part of our universe. It's called like the cosmic dawn. That's the region. It's got a really nice name, and it's the region of the universe where it goes from the dark ages where there's no light, and then you have the cosmic dawn, and everything becomes illuminated and you can see. And that's because the universe becomes transparent. And I mean, if you're not just interested out of the sort of poetic beauty of understanding where the universe, how the universe began, I think it's largely just a lot of cosmology I think I couldn't actually give you a concrete example. A lot of cosmology in this sort of areas is more blue skies research. That's what it's called, which is sort of doing it because it's just trying to understand the nature of the universe better. And when you do blue skies research, you get these results out of it that benefit society in different ways. Not necessarily the direct results of the research, but maybe new techniques will come from this that were required to find out what we needed to find from it. And those techniques could be applied to something much more practical. That's the way with a lot of statistics. Is the statistics is developed in a research environment through something like physics or another area, and then you get the economists to come along and pinch it because they can apply it to something that can make money, right? So that's and the sort of statistics I'm doing is called Bayesian inference, and it's very useful for modeling data in a sort of economic sense. So if you can perfect models in that way, you can improve techniques. There's always new techniques coming out for doing it. Like there's like one technique called Monte Carlo is a kind of statistical technique, and there's loads of different ways of doing Monte Carlo methods, right? And I mean, we're learning about one way which has improved on another way from a few years ago, and because it deals with data that is more difficult because it has some conditions to it that the other method can't really deal with very quickly. Because the thing with coding and computational stuff is that if you have a lot of data, it takes a long time to process it. So you need methods that process it as quickly as possible. So you're optimizing and trying to save time and cost. And these are always improving to meet new requirements. And when they meet a new requirement in research, in physics, you can take that into another discipline, and vice versa, right? We steal, all disciplines steal from each other, and that's probably the main way I know of. There's probably some practical applications I don't actually know of, but
but of course you're in it for the inherent beauty of the cosmic dawn and lighting up the dark ages.
That's why I did physics, right? Because I sort of like the sort of pushing the edge of, I mean, I'm not really there, but in terms of what I'm doing right now, but I find physics interesting on the boundary of understanding the nature of reality and sort of going in that direction of almost philosophy, where it's like really pushing the edge of it. And you can't really get there until you go really far into your degree. I feel like I'm touching that slightly now that I'm in my fourth year, right? But the first 3 years of my degree have been foundational stuff to try and just begin to look at that kind of edge of understanding reality kind of things. And even then, we're still nowhere near, you know.
No, it's almost like you spend the first 3 years of your degree learning to read, so that in the fourth year you can read a book, right? Like
absolutely.
Absolutely. That's definitely true. And I'm sure if you were to carry this on, right, this specific area, and you were to do a PhD or even further, you'd look back at where you are now and think, you know, God, I thought I could read then, but look at, you know, I didn't understand, you know, as we said before, you don't know how much you don't know until you're there. Yeah, no, that's really, really interesting. Thank you
No,
for
yeah,
sharing.
I'm finding it extremely interesting, and it's almost like you don't know where to take it. There's so many. I feel like every session I have with my supervisor, he'll say 10 different things that sound really interesting. It's like I don't have time to look into 10 different things from this one discussion. It's crazy how much learning there is to do, which is what I love, right? And I think that's in essence why we're doing this podcast, right? Because we just want to learn more, and it's really interesting to talk about stuff with each other that the other person knows about and can branch off in different directions that we personally haven't thought about as much.
It's nice. I mean, as a conversation we've had so many times before, but it's nice that we went from our group of friends who basically all did GCSEs together and knew basically the same thing, in life. And now we've all gone so massively apart, and, from flying planes to studying neuroscience to studying statistical physics, like it's just so vastly different. And really, we can, it's weird to think back 7 years, 8 years, isn't it?
No, absolutely. I love listening. I love every time I see one like a friend, because like they've just always got something interesting to say about something they know a lot about, right? And it's just that's the whole point in, not to get too deep, but that's the whole point in life, man. Like just
some philosophical questions coming out at the end of the podcast.
Well, I think thank you very much, Mickey. How do you finish a podcast when there's no guest to thank for
That's true,
visiting?
I guess we could just say that's all we have time for. Thank you so much for listening. Tune in next week to hear more great quality content.
It'll only get better from here, folks.
I think it will. To all of the viewers out here who are seeing the uncut director's edition of this podcast, Jesse, his headphones have died, and so as we were for the first half an hour of the podcast, it is me talking to nobody. No, I can't hear you at all. But I guess to entertain all of the viewers, the thousands of people who have tuned in today, and thank you very much for doing that. My soup is going really well. It's a chicken soup. It's got carrot, onion, and celery. I guess the only person who's going to see this part is you, Jesse, when you're editing it. If you do edit it, maybe no one will see. Maybe I'm just talking to myself, and nobody will ever hear the words that are coming out of my mouth. I could say anything. And in this opportunity that I'm given, talking with no consequence, I can't think of anything at all to say. Wonderful.